I'm your host, Grayson Brulte. Welcome to another episode of SAE Tomorrow Today, a show about emerging technology and trends in mobility with leaders and innovators to make it all happen. On today's episode, we're absolutely honored to be joined by Daniel Langkilde, co-founder and CEO Kognic. On today's episode, we'll discuss end-to-end models, AI, and the future of autonomous driving. We hope you enjoy this episode. Daniel, welcome to the podcast.
Thank you. Great to be here.
It's great to have you here. The world of autonomy, self-driving is changing. The old days of the robotic stack have gone the way, I like to say this term, the way of the dodo bird. And now things are shifting towards AI and especially the new end-to-end models. What are your thoughts on this giant shift towards end-to-end models?
I think it's interesting and exciting, but it's far from proven in practice. So I guess it comes down to, I think many of the established players in autonomy are still pretty committed to sort of a perception, prediction, planning approach to bringing products to market. And then there's a bunch of disruptors who are hoping they can make end-to-end models work better. And time will tell if it's going to work.
If end-to-end models do work, they're validated safe, what happens? Do we have this giant disruption in the market? What happens?
I mean, ultimately, I don't think consumers care how the car drives, as long as it drives safely and that you have a great experience. So I think the value proposition to the customer remains unchanged. I think the big question is, I mean, right now we're the industry is in a state where there's sort of all the ADAS players, and they take a fairly traditional approach, and they can monetize that in the near future. So you can the take rate on ADAS functionality gives you additional margins on selling cars. And that's a pretty low risk approach to kind of developing increasingly automated driving. And then there's the L4s who believe that you can remove the driver if you do certain things. And they've spent 10 years plus now on a sort of perception, prediction, planning stack. Obviously, if someone comes around and shows that an end-to-end trained system is better or as good, then all that investment in the perception, prediction, planning stack is kind of not so valuable anymore, I guess. So that would be sad for them, I suppose. But besides that, I think, it's a lot of is also actually operations and distribution. Like you have to actually put these cars on the road and manage a fleet and so forth. And it's not only about the model that you teach at the core.
From a technical standpoint, what can an end-to-end model unlock that a traditional stack cannot unlock? Obviously there's a cost unlock. It's tremendously cheaper, but what else can it unlock?
Is it though?
I think so. Because if you look at the way it's deployed, and once you get past the development stage and the commercialization stage, it will be cheaper.
I think that remains to be seen in that. So I obviously don't know, so I'm speculating, but that's part of the fun here, I guess, is if you look at the stack that has been dominating for the last 10 years, the rationale is that you can diagnose and debug and better understand what is going on if you have these intermediate representations that you can look into and understand the system. The downside is that every intermediate representation means you lose information. So arguably you will lose performance. And if you can instead learn from observation, you move the problem to curating the data set, and then you ideally could learn everything from just observation in that data set, assuming you are confident that all the data you've observed is reflecting the type of driving you want to actually have done. So whatever you did before in sort of explicitly identifying, road signs and driving behavior and scenarios, you now need to do in collection instead. The raw recordings of people driving need to be confirmed to be as good as they need to be. And then the system, in theory, could learn from that. Whether that is cheaper or not, like there's an awful lot of compute and validation and data collection that is still going to go into training the end-to-end system, that I'm not 100% convinced it's actually cheaper. I'm more interested in it because it might improve performance.
What type of performance unlocks do you think that you'll see?
I mean, the downside of these intermediate representations, where you have kind of forced the model to distill down to something that is human interpretable, means you are losing context. So the subtleties of driving will be kind of forced into round pegs in square holes to some extent. It will be a little bit poorly approximating reality all the time. And as a result, you might get unexpected actions by the car, or you might get poor handling of situations that aren't sufficiently well represented in your training data. So I think end-to-end trained systems tend to be smoother and more natural and maybe a little bit more confident when they work. And when they don't work, they fail catastrophically.
Well, humans fail too. I can't tell you. A day hasn't gone by probably in the last 10 years where I haven't seen somebody staring at a phone when I drive.
No.
And that's all over the world. That's just not the United States. It's all over the world. They're distracted.
Yeah.
And that's it's a huge problem that I think accelerates autonomy, because it point blank, the phone's an addiction, and there's data to back that up, but we all use it. So obviously there's multiple ways to develop autonomy. There's the traditional way. There's the end-to-end way. Where does Kognic sit in the development of all of this?
So Kognic is focused on basically creating and curating and annotating the data sets on which you train and test your models. So regardless of what the models you train are, you need to have examples of reality. You need to either record or theoretically simulate how things behave, and then inform the models about what the desired outcome is. So what has happened with end-to-end learning is that if there is a pattern in recorded data, you can learn that pattern without explicitly telling the model what things are. So obviously this is heavily inspired by progress in the language domain, where you can learn to generate English by just consuming tons of text, assuming it's been written by humans. So people say that, it's sort of unsupervised and you can train LLMs without any annotation and so forth. What I think they forget is we first wrote the internet. Like humans did that. It did not just magically appear. So actually, just yesterday, I read an article in The Information referencing the fact that OpenAI is now seeing rapidly diminishing returns on pre-training. And in that article, they noted that the bottleneck is now the amount of training data they have, and especially the accuracy and the diversity of that data. And it turns out many of the things humans can do is not available online. Like all of the human experience has not yet been written down. So people now pay PhDs and others to sit and write instructions that they then feed into these LLMs to cover things that have not been solved by someone online. And there are similar challenges in autonomous driving, where can you learn everything about driving just from observation? Will you then cover the entire space? Well, probably not. You will probably need to oversample certain parts of the space. And one way to do that is to collect data and annotate data to increase that signal. And there's no getting around this. Like the model type is sort of a lower hierarchy problem than what can you learn from in the first place. And you have to have enough signal to learn from. So Kognic fits into that problem, where you have to instruct the AI what you want it to do. You can either do it by putting together a data set of recordings of humans doing driving the way you think they should drive, or by recording data and annotating it. Like either way, you have to tell the system what you expect. So that's our contribution, is to make it as easy and fast as possible to give instructions to your models.
So let me ask you a hypothetical around the data for ChatGPT. This is all hypothetical because it's not possible because a lot of this text doesn't exist. We had the text from ancient Babylon, ancient Egypt, the Roman Empire, Mongolia with all the technical breakthroughs in Mongolia. If all that text was there and digitized, how much further do you think these models would be along because of this, if you want to call it this great knowledge transfer that came out of Babylonia?
I think the historical information is such a tiny, tiny, tiny piece of all data, right? I think I read some statistic that a modern day human is exposed to as much data in a day today as a person was in their entire lifetime in the 1500s. So I think even if we gathered everything, I'm not 100% sure that's completely accurate, but I think there's something to it that like the exponential growth of information means that most historical data is pretty irrelevant. It's the volume is today. I mean, plenty of people have this position that are far more competent in this matter than I am. Like Jan LeCun, for example, he has pointed out several times that most likely the amount of documented knowledge online is a small subset of everything it means to be human. And therefore, even with unsupervised end-to-end methods, there's an upper bound to what we can learn from the internet. And again, the same applies to driving, right? I mean, it's math at the end of the day. You have a space that has some dimensionality, and you observe things, and you can see patterns in that. And either you have enough data to cover everything that is important and you're able to generalize well enough, or you don't. And what we've found so far with autonomy is that if you constrain the operational design domain, like Waymo is doing, and say, for these areas specifically, I want to drive, and you define very clearly what the dynamic driving task is, which is drive safely, and it's okay if you're a little bit cautious, then you can make it work. It's not clear if you can make it financially tractable. Like, is the cost of operating the fleet versus the economic value of ferrying passengers in a taxi actually a good investment or not? I think that's still an open question. They need to further bring down the marginal cost, I think, in order for it to be really great. But those who invest in Waymo believe they will succeed in that. And I think there's a great case that they will. I'm just saying, I think the choice of different type of machine learning models, ultimately it comes down to, can we realistically learn a task because it's frequently recurring enough in a sufficiently well-defined ODD such that we can make money from it? And that question is still a work in progress.
It's coming. There was a report I read over the weekend from Evercore. They broke down the cost of the Waymo vehicle are going down. It's actually interesting. The cost in San Francisco were almost on par with UberX, and we're seeing it. And this was on the Uber earnings call. The 10% drop in Uber rides and Dara Khosrowshahi is looking at the Waymo. If Waymo continue to get the cost down, it could become profitable. It's going to have to get more scale, and the costs are going to have to continue to come down, especially from the integration costs that are very, very expensive when they build the vehicle.
Yeah, I mean, again, I'm not pessimistic about this. I'm just saying, I think my point is more when it comes to technology choices and sort of which method is best. I think depending on your time frame, the answer is going to be in the financial tractability of it. What method is best? If sticking to the perception, prediction, planning path in order to get both I'm not so worried about the vehicles actually, because I think that's a relatively marginal cost. I think the cost is about like how many stranded vehicles do you get per hour? What's the cost of retrieving those vehicles? What's the continuous cost of maintaining the HD maps and the perception systems? What's the amount of compute in updating your planning and prediction system to cope with changes in behavior? Like those kinds of ongoing costs, I think, are the big challenge. The car is going to be industrialized and low cost eventually anyway. I mean, sensors, I think when Kognic started, a LiDAR from Velodyne was like $10,000, $15,000. And today you can get one for like $400. So that part is, I think, going to be solved, no problem. I think humans are so incredibly resource efficient in our ability to learn, and we are actually rather cheap to maintain. So the challenge for AI is like, how can we make someone eat as little as a human and still do so many things?
Feed them Wheaties.
Yeah. I mean, right now they are living off NVIDIA GPUs, and those certainly aren't cheap.
No, but those are going to come down as more competition.
I agree.
Comes into the market.
Yeah.
They can only hold that monopoly so long. You could we go down a history lane about the cost and how it's going to drop. So with your platform, what type of sensor data are you pulling in? Are you pulling in LiDAR data, radar data, camera data when they know it? What type of data are you pulling into your system?
Yeah, so I think our main advantage that we focused on is the multimodal sort of sensor fusion setup where you have camera, LiDAR, radar in some combination. So obviously the space of like data sets and data annotation is large by now. You can do text, you can do 2D images, you can do X-ray images, whatever. There are lots of stuff. We have decided since many years ago, we're now been around for about 7 years, that we were going to focus exclusively on ADAS and AD and sensor fusion. So we only do data annotation and data set kind of production for ADAS and AD companies. And then it's a question of camera, LiDAR, radar. So typically there's also long sequences and like large complex scenes. So you might have like a 30-second clip or even longer where you have lots of dynamic objects, lots of, you need to be able to resolve instances across time and understand how they move about, both for training and for validation. So that's really our sweet spot.
One of your customers, public customers, Kognic, you've got their CTO, Andy, who's a wonderful gentleman. Why did Andy and the team at Kognic choose to go with your platform?
So I was just there visiting them last week, and I think they pointed to a few things. First of all, they really appreciate our deep focus on sensor fusion. So there are lots of things you can unlock if you thoroughly understand how time and space works in a global coordinate system for complicated and complex data. So we've really kind of hammered out a lot of low-level details that if you are playing a more horizontal game, maybe don't think is worthwhile. So we've really gone, deep in that. The other thing is by only doing AD and ADAS, we have a team that is highly specialized and highly focused on this, which means, we have experience and insights that can further help Kognic save money and reduce how much they spend on data. Because our goal is always to sell as little annotation as we can, as cheaply as we can, because no one wants to spend money on that stuff for good reason. So by developing a technology platform to minimize this, we can give an attractive alternative to our customers.
Before Kognic, what was in the market? Was there another competing product in the market, or did you just see an opportunity in the market to create a product that can help your customers accelerate?
So I used to be in intelligence in the past, and I was a machine learning engineer processing very large amounts of text at one point. And it became clear to me quite quickly that the bottleneck was the training data. And it doesn't matter, again, if it's unsupervised or supervised. It's like volume of high quality text was a huge matter for the kind of work I did in the past. So I started, and this is like 15 years ago. And there have been dataset and annotation companies around for a long time. It's just that the technology has changed so that the model by which you engage has changed over time. So I was a customer of some of that time's leading annotation companies. One that I remember clearly was Crowdflower. I think they changed names to Figure 8 at one point. And at the very beginning, they were called Dolores Labs. They were like a source of inspiration for me, both in a good and a bad way. Like I liked what they were doing, but I kind of hated their product. So as a buyer of annotations, I had huge issues getting their stuff to work. So as I decided to set out and build my own company, I figured, okay, there should be a way to make the experience less painful for machine learning engineers. And there are a handful of other annotation companies, some larger than others, I think today we are one of the few, if not the only one, that is exclusively focused on sensor fusion for ADAS and AD. And we sort of embrace that focus and willingly sacrifice some addressable market in favor of being very specialized.
Well, specialized is healthy because it's scalable and you're not trying to be a Swiss Army knife or a jack of all trades. As we see in corporate history, you get bogged down when you try and be too much to too many people. Staying on the too much theme, how much data is too much data? Is there such a thing as too much data when you come to developing an autonomous driving set?
So the key is having useful data that contains value, right? The volume as such, I have an example from, we'll let the people involved be anonymous, but I had an example where someone was tasked with training a system to detect tires on the road. So if someone like had a piece of rubber, the tire exploded and there's rubber on the road, or someone dropped the tire even. So they understood they needed a lot of data of this. So they put 5 tires on a road and drove around them for 2 hours. And they then said, oh, we now have a ton of recordings of tires off the road. But what they had was 5 specific tires in the same location for 2 hours from different angles. Like, I think it's, to someone doing machine learning, it's pretty obvious that's not the point. And you need something different. But everything are degrees of that, right? Like what is the necessary diversity of the data set? Well, what you need is whatever is hard for your model but important, you need more of until it's not hard. And the secret, like Kodiak, for example, I want to give them huge credit for being incredibly resource efficient. One of the things that impressed me the most every time I visit them is their frugality, their ability to do so much from so little. And that's because they are very deliberate about what data they collect and what they pass forward in their pipeline. And without naming someone specifically, like the legacy OEMs and tier ones tend to have a more requirements-driven waterfall approach where you say, I want this much data and it should be annotated like this. And in the end, you have like 2 hours of driving straight on the highway with trailing a car. And it's like, why did you store all this? This is just bloat. So yes, there is such a thing as too much data, but you can't have too much valuable data.
Does valuable data become the priority data? And if so, how do you label priority valuable data versus non-priority non-valuable data?
Yeah, great question. I mean, in the academic sense, there's the concept of sort of active learning where every machine learning model has kind of a decision boundary, and things that are close to the decision boundary are usually confusing for the model. Or if you're like the loss in the model is high. So basically, no matter how long you train, it's still not sure what to do about certain examples. Maybe you have conflicting information in your data set. So for example, and this, all of what I'm saying now applies equally to end-to-end learning as it does to supervised learning. If you have 2 recordings in a data set of a specific scenario where drivers take radically opposite solutions to the problem, one does one thing and the other one does something completely different. No machine learning model can learn from that. It will cancel each other out, basically, unless there's sufficient detail to identify why the drivers did different things, which may not even be there in the first place. It might just be random. So like consistency of interpretation is a huge part of getting high performance from machine learning, and identifying where there is uncertainty. That is a big part. So active learning can be one approach, like looking at embedding things to see what is out of sample or out of distribution. There are many different ways, but it comes down to finding inconsistencies and uncertainties.
Is there an ideal data set for pre-learning when it comes to teaching a model to drive a vehicle?
I mean, I think the ideal approach, I don't think this, that's also a misconception that I dislike, in that there is such a thing as a data set that is static. Like it's an organism almost. you have to continuously curate and grow your data set and remove the stuff that is maybe redundant or duplicate, add things that cover new parts of your ODD. Whenever you find unexpected behavior, you need to add that. So it's like an evolving thing. I think that's what Tesla did. That their best part of their FSD approach for me is clearly that they do fleet insight, where the cars trigger data collection based on what drivers give feedback on and what the system is unsure about, so that you can, in a very precise way, grow your data set only with the stuff that is most valuable. And then you're sort of boiling the ocean, which a lot of people are debating whether they will succeed in that or not. I think a smart person I know at an L4 company told me the other day, we can't avoid boiling the ocean. The challenge is building a fusion reactor that will raise the temperature enough.
Yeah, I own a Tesla. I use FSD. I actually used it this morning. It works really well, and I've noticed every update incrementally gets better and better. And I've said this, and I'll say this again for the record. I believe it's only a matter of time until they crack FSD. I'm not going to give you a timeline. I'm not going to give you a when, but I believe at some point in the future they will crack full self-driving unsupervised. When you take so Tesla's primarily running FSD in America. Yes, they're going for Europe approval. Yes, they're going for mainland China approval. And right now, if you look at Baidu is now looking at expanding into Malaysia. There is some movements in from mainland China to Hong Kong, and so there's some movements from Australia to China. So we're starting to see that movement. When you start operating in multiple countries with different rules and regulations, customs and cultures, I think, plays a very big part, especially if you're going to go into India, different customs and cultures. How does the data set have to change, and just because of the way that traditional individuals drive?
Fortunately, physics works the same everywhere. So at least we don't have to learn that several times. Mass has certain properties and velocities and momentums and so forth. But you're absolutely right that like intent and how people move and how they react in dynamic situations obviously differs from different countries. And there are also different traffic laws, etc. So again, coming back to sort of the pros and cons of end-to-end learning versus sort of a stack with intermediate representations. I think if you can just capture enough data and you can curate that data well enough, you can learn to drive anywhere. And then depending on how messy the traffic situation is, that just determines how much data you need and maybe how much of continuous data collection you need. So if the roads keep changing, like if construction is going up everywhere and there's obstacles moving around and so forth, there's no way you can solve that with HD maps because maintaining them would just be too costly. So then I think a vision-first approach like Tesla is applying is the more long-term realistic approach. I mean, my issue with, to the extent I have an issue with Tesla's approach, I have no technical issues with their approach. I think the issue is more about sort of long-term, short-term. I think long-term, of course, a vision-first, end-to-end learned approach should bring the highest performance. It's just a matter of like, how do you verify and validate the safety of that system and how long does it take before it gets good enough? And maybe that doesn't matter. Maybe just iterating forever is fine. As long as it depends, it comes down to cost of capital and shareholder happiness and so forth. But if you can handle that part, which clearly Tesla can, then you're fine. Like machine learning is pretty simple in its core, right? It's a matter of, can I represent things that happen in such a way that I can recognize them the next time and know what to do? And the problem with reality is that almost nothing ever happens. And if it happens, it almost never happens twice. At least not if you look too closely. So the trick, and I think this is because there's just not enough berries in the forest. Like humans evolved to kind of squint. We look at reality, but we kind of ignore most of it because If we had to process everything all the time, we would run out of food. It's just too expensive. So we kind of squint and we only try and look for the most important parts. And then if you're successful in that, you can handle a lot of diversity without too much effort. So machine learning and computers in general, I mean, in the past, computers have suffered from the issue that they have been super anal about stuff, right? Like if a 1 is a 1 and it's a 1. But now you can we have sort of reduced the resolution, if you will. AI can now squint and ignore a lot of stuff in order to only focus on the parts that are most important. And as the years go by, we increase the amount of parameters in these models. We increase the amount of data available. That lets us have even more nuanced representations, which means we can find even more complicated patterns or rare patterns. So the whole key to AI is like making rare things common without being bad at stuff. And end-to-end learning is great at finding subtle patterns, but it is highly dependent on very large data sets instead. So with human supervision, you can kind of bootstrap by encoding human expertise at the expense of granularity and nuance. And that's the trade-off space we're now navigating. Like, how far can we get with just brute force, massive amounts of data, lots of parameters, versus kind of injecting expert knowledge? And I don't think it's either or. It's like an iterative evolution where it's a short-term, long-term problem at the same time.
A lot's going to change. How many models as autonomy and self-driving evolves do you see coming onto the market? Do you see several different approaches, or do you see the industry kind of unify around one approach with, if you want to use the term, forks or variations to it?
Super hard to know. I don't know. I mean, I think the part of the excitement about being in this space is that it's somewhat unpredictable, and we constantly get new breakthroughs that change things in a way that is hard to anticipate. I mean, if you go back 10 years, I don't think anyone expected, a wave to appear with this force this quickly at this point in time, maybe. Who knows what the next wave is in 5 years? Maybe there's another radically different approach. And at that point, Wave is maybe so invested in their approach that the switching cost is huge. Like the challenge for incumbents is that if you worked for 10 years and spent 5 or 10 or 50 billion at something, it's a little bit harder to just say, fuck it, I'll throw that away and do something else, even if it's maybe better. And that's, I think, another strength in Tesla is they have the tendency to just say, out with the old, in with the new. Don't care how much sunken cost I have. I'm just going to try this other thing, which I find very inspiring. But it makes it very, very hard to predict what's going to happen.
Tesla's very, very inspiring. If you look at this as potential, there's a paper on this. I'm not saying they're going to do it, but they did publish a paper. Waymo published a paper on their Emma model. What are your thoughts on the Emma model? And could that eventually replace the traditional model that Waymo's using today?
So last I spoke to members of the Waymo team, they were still very heavily reliant on the perception, prediction, planning approach. And they're very kind of entrenched in that, I think, for their production system. At maybe a year or two ago, to my knowledge, they still did not even have a neural planner in production. Maybe that's changed since then. I'm not privy to the details, but I don't hold that against them. I mean, they have a very specific goal. They want to deliver an extremely safe robotaxi experience in a constrained ODD using HD maps and a few other things. I think the trick here that they could pull off is if there's a way to move to a more general system that is less reliant on detailed engineering and can more live off large-scale data collection, that's the way they can lower the cost of expanding the ODD. And ideally, they could seamlessly switch from one to the other and even have the old method as the guardrails for the new one in the in-between. So I don't think one day they will just flip a switch and it's suddenly end to end. I think it's going to be both systems running in parallel until they feel comfortable enough to maybe rely mostly on the other. And then hopefully that unlocks a new cost structure that makes the whole endeavor more viable.
It's very nice to have Alphabet resources to be able to do this, because outside of Tesla, they're the only ones that have the capital to try these various different models. Could you see a point where Waymo in a controlled ODD, perhaps on a proving ground, test the Emma model by itself just to see in vehicles in a controlled environment?
I'm assuming they are doing that. I don't know any internal details that of Waymo, but at this point, but I'm certain they are, at least in their simulators, testing the end-to-end systems, and I'm sure they are doing some real-world testing as well. There's certainly a big subset of driving that can be learned in a very general way. I mean, you don't have to, if you have a good image recognition algorithm trained on all images from everywhere in the world, there's no need to learn that again for driving. So leveraging Gemini or whatever other foundational models for 2D image space makes total sense to me. The question is, how much vertically specific, sort of domain specific knowledge do you need to add on top of these general purpose foundational models? And I think part of that problem is that there isn't a ton of driving online. I mean, if you scrape the internet to learn about the world, there's very little available training data for driving online. You have to kind of create it yourself. So I don't think they will ever get away with using consumer foundational models to drive, or maybe in the far future, who knows? But realistically, it is a specific skill that you need to learn by observing that specific behavior.
But you could say maybe that's the advantage of Tesla, because the millions of miles they're gathering every single day of incidents, stop signs. I was amazed. I was my FSD out for a test drive the other day, and there's a construction, they have a stop sign, and then the guy waves, and the car knew, okay, when he waved to go. Okay, this is pretty amazing. So, but that's an incident that you can't learn by scraping the internet. In your opinion, Daniel, what is the future of AI in autonomy? What is it going to look like?
I mean, my vision, and the vision that underpins the company, is that everything that moves will be autonomous. So, I mean, I have always been maybe a weird mix of hyper realist and still very visionary about the fact that I'm super excited about both self-driving cars and robots in general. I think as an entrepreneur who is trying to build a viable business, you also have to, it's all about short-term, long-term, and sort of how do you monetize versus how much capital can you access, and what's the sort of path you take through that. So my expectation is that, number one, most cars today are dumb as toasters. There's 80 million cars sold every year, and I think only about 10% have an L2 system. Half of them don't even have cruise control, as far as I know. So that means there are 40 million brand new cars rolling out every year that can't even set the speed. So let's fix that. And then we will sort of nibble from one side on the higher levels of autonomy. So from a commercial standpoint, just increasing L2 penetration in new car sales from 10 to 30% in the next 5 years is a huge market financially. And that's one that I'm pursuing commercially short term. And then there's, another more high risk, high reward approach where you say, all right, let's skip ADAS and go straight to AD. Can we commercialize that? And I think you can too. It's just a matter of having enough capital and enough risk appetite, like Tesla and like Alphabet. It makes sense. I'm excited. I think it's going to happen. I think it's going to take longer than they would like, but sooner than the pessimists think. Which is kind of what's been true for Tesla the whole time. If you're a party pooper, you can always say they never hit their timelines. But on the other hand, they've always, delivered 10 times more than everyone who just complains. So in the end, I would take the progress over the consistency in estimating time.
We saw what happened, up 38% last week. The Tesla shorts, they got burnt to the ground, lost billions. The optimistic, believing in Elon, got wildly rewarded. My attitude is, like the company, not like the company. Be optimistic, because what they're building is truly remarkable and truly revolutionary. And what you're building at Kognic is allowing your customers, as Kodiak, to scale, to build safer systems, to deploy them more cost effective. And I love the line, and I agree with you. Everything that moves will be autonomous. I'm going to say that again. Everything that moves will be autonomous. You are 100% correct, Daniel. As we look to wrap up this insightful conversation for today, what would you like our listeners to take away with them?
I mean, I think regardless of what models you train or what approach you take to autonomy, the key to unlocking performance is going to be the data set. That's my deep conviction. And it doesn't matter if you're training a supervised system or not. And it's not about sort of labeling a ton of bounding boxes. I think that's going away pretty quickly. I think the long-term necessary thing here is, how do you know if the sum of the data will result in the behavior you want from your car? Because it will do whatever is in the data set. And we need to curate and organize this data so that the driving behavior lives up to our expectations. And my goal with the company is to figure out the most resource efficient, the most productive way to shape these data sets so that the behavior of the product is what you want it to be. And Tesla is a great source of inspiration. You know, they have this rate driving clips, like if they were an Uber driver, you know, the car records something and it sends it up to the cloud, and someone goes in and says, if you were a passenger in this car for 30 seconds, would you be happy or not happy? You know, that's a sort of annotation where you are asking for preferences. And then if the human says, oh my God, I don't want to ride in a car like this, you just remove that from the data set. If they say, oh, amazing, that's a 5-star ride, let's get more of that. And that way you can incrementally build a large data set that ultimately delivers a great customer experience. Because customers just want a smooth, safe drive when they can do something else. They don't care if it's made using AI or, you know, whatever. It doesn't matter. It's the customer experience that matters. And I think the path there is through the data.
At the end of the day, the customer is always right. So go build the future. Today is tomorrow. Tomorrow is today. The future is AI. Daniel, thank you so much for coming on SAE Tomorrow Today.
Thank you for having me. It was a lot of fun.
Thank you for listening to SAE Tomorrow Today. Be sure to join us next week as we step into the future with Space Perspective, the world's first carbon-neutral spaceflight experience.
SAE International makes no representations as to the accuracy of the information presented in this podcast. The information and opinions are for general information only. SAE International does not endorse, approve, recommend, or certify any information, product, process, service, or organization presented or mentioned in this podcast.